Yes, indeed. My name is Ivan, and I work in the Cifrum company, which is the competence center from ROSATOM, and it's an end-to-end competence center. We will be talking about mathematical models implementations based upon machine learning in the machine building industry. We'll be speaking about the company which possesses the assets and competences throughout the entire atomic energy value chain, from uranium production to actual maintenance, construction, and artificial intelligence as well. Machine learning has been used in main production processes, the analysis of the operability of the equipment, industrial safety, and other aspects, as well as risk management. We will be speaking about one of the stages of the production process, the fabrication of the nuclear fuel from the hexafluoride conversion to the oxide of the uranium powder and the production of fuel cells. We will be considering just the production of the fuel cells and fuel tablets from hexafluoride of uranium. It starts with the mixture process of the powder with the plasticizer, then it goes to the granulation unit, then it goes to the pressing equipment where the tablets are made, then they are sent to the assay, and then a set of tablets is manufactured with additional control applied. We have been focusing on the planned maintenance of the granulation units. Unfortunately, the speaker sound is interrupting without actually reducing the volume of the products. The second item is the furnaces. The furnaces are the most important link. In case of its critical damage, less time is required. And the third item is the existing production technology creates abnormalities in the structure, like fractures, for example. This affects the production of these abnormalities in the microstructure. So far, we have been focusing on the granulation unit. The resolution of these problems started with the mathematical models, the early determination models, which cover the problems with the unplanned downtime at the early stages of the industrial process. We don't have too much time for this presentation, so I'll be speaking about a large number of the unplanned downtimes and shutdowns caused by the faulty equipment. The early detection model will help us provide some planning time and allocate time for maintenance. We started with data analysis. We started having data from the data collection system approximately for 2 years. It contains information about the equipment, like temperature, spinning speed, aperture, approximately 17 signals, and it samples 5 times per second. For an appropriate mode, operation mode, we've been using the maintenance journal log, where we point out the events. We use the recurrent system. This model is comparing this state with the planned one. The difference Unfortunately, the sound constantly interrupts. I can't seem to hear the speaker properly. Yet another division is the remaining resource of the equipment. We don't have any historic data about this remaining resource, so we have analyzed other features based upon physical models, like the spinning speed. The higher the speed of the drill bit, the higher the regression. So we are using the models, the predictive models, and we are planning a month ahead. We have developed two types of models. First of all, the early detection model, and then the remaining resource. And as far as the indicator of the technical state is concerned, this model works with parameters that are benchmarked and compared with the current values. Then each signal is analyzed and the indicator is made up with the control limit applied to it, and in case this control limit is exceeded, the staff members are getting signals about faults in the equipment's operational performance. At one of the units in the middle of June, there were deviations detected. As the result, ball bearings were detected faulty, and the decision was made about fixing it. After the repair, everything went back to norm. Yet another case is about powder unit utilizing a different technology. This type of powder leads to the non-stable operation of the unit, which very quickly reduces its resource and operation time. There was no solution available, but we decided not to apply that to the model, and we decided to take that instability into account beforehand. What do we have currently? We have mathematical models available that are bringing use, and the early deviation detection models about these granulating units and furnaces, and the prediction models at the granulation stage of powder processing. We've been using web applications for that, and we've used Djangis with the Lotley and Dash libraries available. We've integrated that with the sources of data to gain the information in time, and we've launched the pilot tests, and we carry on investigating. We have not stopped on that, and we keep on enriching these models with some other data covering other stages of the production cycle. Some of the faults cannot be detected and forecasted by using the data which have been collected from the equipment, so we'll have to tackle the improved solutions and install more sensors. We would like to connect additional equipment there which would be involved in the early stages of the production cycle, like all of the presses. And this one relates least to machine learning, but this proves to be problematic if missed. Like, for example, the turnover time and the processing time required to process a specific unit of production. We decided to optimize certain stages of the production process. Now we're switching to the optimization of the entire production line. There have been plenty of models planned, and of course we just need to develop some kind of infrastructural solutions, and we need to have life cycle maintenance, we need to have additional data integration and other things. Everything requires us to install a platform solution. We have prepared good soil for that, and we understand the bottlenecks of the process, and we understand what we need to integrate it with. Thank you very much. I'm done. Thank you very much. I will be happy to contact you by mail or by telegram, so I'll be taking your questions later if you're not going to ask them right now. Ivan, thank you very much for your presentation. Yes, I did promise that I'm going to come up with some trick questions, which I'm going to do right now. As your colleague, I think I'll be very frequently asking this question during the course of this session. Is there any tangible effect from the implementation of predictable analytics, and what kind of effects are? Yes, there are effects with those pilot tests. So we carry out these days with this machine building facility. Economically speaking, they are quite transparent, which is the reduction of the time of the unplanned downtime. As far as the direct economic effects, there are some other effects involved, which will help us later on as we digitize the paper logs that contain useful information. It's just one of the examples, and gathering of some additional data. Like, for example, the sensors had been installed, but the data has not been collected from there, or it was just collected in the cyclic buffer and was rewritten after every 4 months. Of course, they use this information about for some other reasons, but we just need to accumulate this data. That's what we reveal, and there are plenty of such effects around. Ivan, thank you very much. It was clear about the effects. It's okay. But still, in terms of the monetization of these effects, in Rosatom, is there a magic solution about how to visualize these predictable analytics solutions? Is there any economic effect? Yes, economically they just pull out clear economic effect. At the early stages, we take that shipment and we do not launch it at the rest of the production chain. So obviously there is a tangible economic effect from that. I think the overhaul and repair and maintenance time and downtime time is a very relatable topic for many industries, and the video analytics and predictable analytics are topics that are quite relevant for us as the major players of the industry. Thank you very much, Ivan, for your interesting presentation.